Hello everyone. In this uh, in this slides we are going to learn about semaphores in operating system and also the mutex versus semaphores. So basically this slides contain some contents. First one is semaphores, second one is type of semaphores and the advantages of semaphores, disadvantages of semaphores, mutex and semaphores versus mutex. So moving further, we are we are going to learn about semaphores. So semaphores are basically integer variables that are used to solve the critical section problems by using two atomic operations, wait and signal, that are used for process synchronization. In the next slide, we are going to learn about what is wait and signal. So basically wait is the operation decrement the value of its arguments. It is positive and it is negative or zero, then no operation is performed. So basically in next we are going to learn about signals. Signals are the operation increments the value of its arguments s. After this topic we are going to learn about types of semaphores. So basically there are two types of semaphores. First one is counting semaphores. So what is counting semaphores? These are the integer value semaphores and have an unrestricted value domain. The next one is binary semaphores. The binary semaphores are like counting semaphores, but their value is restricted between 0 and 1. So in the next one we are going to learn about the advantages of semaphores. Semaphores allows only one process into the critical situation. They follow the mutual exclusion principle strictly and are much more efficient than some other methods of synchronization. The other advantage of semaphores is there is no resource wastage. Because of busy waiting in semaphores as processor time, it is not wasted unnecessary to check if a condition is fulfilled to allow a process to access the critical section. Semaphores are implemented in the machine independent code of microkernels, so they are machine independent. The next we are going to learn about the disadvantages of semaphores. Semaphores is complicated, so the wait and signal operations must be implemented in the correct order to prevent deadlocks. The next disadvantages is semaphores may lead to a priority inversion where low priority processes may access the critical section first and high priority process later. The another disadvantages of semaphores is semaphores are impractical for the large scales use as their use leads to the laws of modularity. This happens because the wait and signal operation prevents the creation of a structure layout for the system. In the next slides, we are going to learn about the mutex. So basically, the full form of mutex is mutual exclusion object. It is a special type of binary semaphore which is used for controlling access to the shared resources. Basically, it includes a priority inheritance mechanism to avoid extend priority inversion problems. It allows current higher priority tasks to kept in the block state for the shortcut for the shortest time possible. However, priority inheritance does not correct priority inversion but only minimize its efforts. So in the next slides, we are going to learn about the difference between semaphores and mutex. After this, semaphores is an integer variable. The next, the wait and the signal operations can modify a semaphore. You can have multiple program threads. The value can be changed by any process releasing or obtaining the resources. Type of semaphores are counting semaphores and binary semaphores. Semaphores value is modified using wait and signal operation. So moving towards further, we are going to see mutex. Mutex is a locking mechanism. Mutex is just an object. It is modified only by the process that may request or release a resource. You can have multiple programs threads in mutex but not simultaneously. Mutex has no subtypes and mutex object is locked or unlocked. So thank you for watching this PPT.